We're building a new aluminum expedition sailboat, and over the last 12 months, we've been documenting the hull construction as well as systems design for the hybrid electric diesel drive system. Check out the build series here if you missed any videos, and add a comment below if you have any additional topics you're interested in. This time on Distant Shores, we go into depth on lithium batteries, planning out the boat's energy storage system, and touring the Super B battery factory, where we learn how marine lithium batteries are manufactured.
We're Cheryl and Paul Shard, hosts of the Distant Shores Sailing Adventure TV series. We've been cruising and living aboard for 33 years, documenting the sailing lifestyle. Join us for the building of our fifth boat, a custom aluminum Orion 49.
Our new boat has been designed from the start to have a hybrid electric drive system with a 15 kilowatt electric motor as well as a standard diesel engine for propulsion. This means we will need a high energy capacity to give us a meaningful range in electric mode. Electrical energy is measured in kilowatt hours. Think about kilowatt hours as equivalent to how much fuel you carry in the tank, and I calculated we need about 30 kilowatt hours. I estimate this would give us 2 hours at full speed in electric mode, roughly 5.5 knots, or for longer range, 6 hours at roughly 3.5 knots. A 30 kilowatt hour lithium battery bank will likely weigh more than 200 kilograms, so for stability it will be best to have the batteries located low in the boat. We've been looking at battery manufacturers who build a high-quality marine battery that will allow us to fit the large capacity and reliable battery bank we'll need, and heard about a Netherlands-based company about 2 hours from Mackham called Super B.
So as you see, we've got 4 main production lines. It starts with the starter line, which is actually the product we started with as Super B for starting engines. Those are relatively small batteries. With a 25 ampere-hour starter battery, we can produce 1000 amps on starting current. So very high peaks, but not suitable for, let's say, energy usage, long-term energy consumption.
Roy shows us the building block for their first production starting battery, a 26650 cell, meaning 26mm diameter, 65mm length cylindrical cell, producing 3.2 volts.
Each lithium iron phosphate cell, that's how you can recognize it, is always nominal voltage 3.2 volts. Put 4 in series, then you have a 12.8 volt, say 12 volt battery.
All the batteries here at Super B are based on the lithium iron phosphate chemistry. Lithium iron phosphate, or lithium ferrophosphate, is written LiFePO4, for the Li for lithium, Fe for ferro, and PO4 for phosphate.
There's also our smallest battery, a 2.5 ampere-hour starting battery. It's like this size, and that is used for starting like 250cc motorcycle engines. Completely different than, of course, the energy batteries, where there is much more electronics inside.
For boat batteries, our main goal is maximum energy storage.
Here we use different types of cell. This is what we call a prismatic shaped cell, this blue one. Again, lithium iron phosphate, so one of these blue things is 3.2 volts. In this battery we have 4 in series and 2 in parallel.
With 4 cells in series, we get a battery voltage of 12.8 volts, and if we want to double the energy available, we can add 4 more series cells, but connect them in parallel, where the voltage remains 12.8, but the energy in the current doubles.
And this entire battery is 340 ampere hours.
Oh wow, yeah.
And here you can again see we do not screw cells like many competitors, but we weld the cells together because we think welding is a far better connection than screwing, especially over time. The advantage of prismatic over cylindrical is that you can achieve a higher energy density level than with cylindrical, because cylindrical there's still quite some air in between. Here you can again see the type of weld we do. It's not a spot weld, but it really makes a complete circle. Also again to reduce the resistance within the battery. If we design a battery, that's always a good example. We try to keep everything around the cell should stay cooler than the cell itself. when you discharge or charge the battery. So nothing like cables or bus bars is allowed to heat up the cells. So meaning we use quite thick materials to connect. And one example is, for example, this type of bolt you see here. It's not just a bolt. It's CNC phrased again to be completely flat. And then the material used here,
this face is specially machined.
Exactly. So it's entirely flat, if you can see. Normally a bolt is like curved, but this is entirely flat. And then this material here, it's aluminum, but it's tin-plated aluminum. Tin is a soft material, so when you press the bolt, it presses inside the material and then you have perfect connection.
Yeah. Wow.
Now each and every component, it's labeled. Like here you have these barcodes. It's on the cell, it's on the cabling, it's on the entire BMS, and every component is scanned and tracked into the system. So afterwards you can always see if there's a default in the field. We can trace back, okay, which is the batch and did we see that more often in this batch, so we know there's a problem.
Okay.
Also, it's also checking this guy that's making the battery, that he actually had training to make this battery, so he should log into the system before he can actually produce the battery.
Oh, I see. So you can trace even that.
Fully traceable.
Yeah.
Yes.
Wow.
Yes.
Clearly, safety and quality control is a priority at Super B batteries.
So that's actually the largest battery we produce, 12 volt, 340 ampere hours. And there you can also see the development which we made in the past couple of years, because we started in that same battery casing with 160 ampere hours. That was 6 years ago, and now we're at 340. You see again the two cells, prismatic cells again. They actually put on the side so it fits perfectly in this casing. 4 cells, that means to make a 12 volt battery, these are all in series.
Is this the inside of what's inside the Nomada then?
This here.
That's the configuration?
Yeah, it's put like this, it puts into the battery. And everything is computer controlled, like this device, it knows exactly, okay, I'm now having this type of screw and I need to tighten it with so many Newton meters to reduce all kinds of errors in the field, right?
Perfect.
Yeah, I do it.
Please, Johan, please.
This style of battery is what we're planning for our boat, so we're interested to watch one made. First, sealant adhesive is put in to secure the cells and prevent vibration. Next, an assembly of 2 cells is set in one end of the case and then the other. These 4 cells, each with 3.2 volts, will make up the 12.8 volt battery. The upper assembly comes next, securing the cells in place and connecting the cells to handle the heavy current flowing from the battery.
What I always find interesting, this is only the top side, but the back side, you see how thick this is. Because you can discharge this 105 ampere hour with 315 amps, so then you need to have these kind of thick materials. And of course that's also what makes Super B a little bit more expensive, that we use those kind of thick materials. Yes, it's an expensive material, but we really think it makes a better battery.
I see. Yes, it looks very...
Yeah, all CNC phrased, very thick aluminum.
That's aluminium.
Yeah.
Yeah.
This jig holds the battery case in perfect shape while the upper components are added.
So that's the shunt.
The shunt?
Oh, okay.
So you know how much current is floating within the battery. Yeah.
The shunt monitors the energy that flows in and out of a battery. In this case, having the shunt right inside the battery allows the battery to monitor itself, measuring the real-time current draw as well as the battery voltage.
Als komt er eentje komen,
Ja.
hoort hij wel.
But you can also see, these are the temperature sensors, so we measure the temperature of each individual cell.
So there's 4, this is...
Yeah, 4 in
There's
total.
4 cells. So we're scanning in the job that we're doing now?
Yeah, and also to trace, okay, this part then belongs to the, you need to scan the BMS that comes on top here. So we need to make sure, okay, this cell pack with these components matches with that BMS.
The BMS, Battery Management System, is an electronic system that manages the battery pack, protecting the battery from operating outside its safe operating zone, monitoring its state, balancing the individual cells, and telling the charger when to turn off. Finally, the top cover can be put on, sealing the battery to its waterproof IP66 standard. Then it's ready to be put on the test stand, where each individual battery is run through testing and a couple of cycles, again checked by the scan code.
She's finished?
Finished.
One?
That's gone.
Yep.
This one.
Oh, so now it's going on to a test jig, or test stand. So all that is automatically being calculated if it's okay. How long does it take to make one?
20 days. 20 on a day.
20 per day.
Yeah.
20 per day.
20 per
Yeah.
day. Hello.
How long have you worked here?
2 years.
2 years?
2.5 years.
It's a very nice space to work in, I
Yeah.
think.
Yeah.
This.
And I would not 3 years and then it's gone.
Retirement or what?
Ja.
Are you gonna-
Not an issue.
Ja, maar het mag ook een keer. Ik heb al 44 jaar gewerkt, dus
Yeah,
44 years.
he has been working in total.
Yep. Time to retire.
I think I will not make 44 years.
This is a nice place to spend some time working, though.
Yeah.
This is
And it's
very
clean
nice
also.
factory. It's a very clean, beautiful environment for everybody.
Yeah. No, and it's we try to make it as comfortable as possible, not to lift every time the battery, but just as these roller skates to move it around.
So it's doing a test now. That's what it's finishing the test.
And it does some cycles. Hey, you see here, for example, as well. It sees the voltages on the different cells, and you immediately do the balancing here. So we charge it to 100%. So it's charged up to 100% before it goes in the warehouse. And when it's shipped from the warehouse to the customer, before we hook it up very quickly again to make sure that when it arrives at the customer, it's perfectly charged and ready for use and balanced. Yeah. And you see, those are already finished and it says passed. And of course, all that information is also again stored in the system. That when an error happens in the field, we can see, hey, did this actually pass the test, and were there any strange data to be found?
So these are the bus connections?
Yeah, this orange cable. Yeah.
Nomada has a different kind of...
No, it's the same type of connector. It only has 3. Because that's a battery we use in a larger system, so you want to wire it through, which is why we have 3. If this battery is only 1, meaning if you want to connect to another one, you have to use a splitter in between. And that one you can simply wire through. And a third connector is required by DNV, which is a maritime commercial type approval. And that required a BMS independent temperature sensor. So suppose all temperature sensors on the entire BMS would fail, the third connector is an additional temperature sensor, because DNV thinks temperature is very crucial on board of ships, and it's the one thing to keep it under control, the most important thing to keep it under control. So even if the BMS would fail and the temperature would run too high, it would spit out a temperature warning.
I hadn't heard of this additional safety feature before. This battery has already got 4 temperature sensors connected to the battery management system, one for each individual cell. But then, for even more safety, there's an extra temperature sensor set up independent of the BMS.
DNV is a maritime type approval for commercial ships. So if you want to install lithium batteries for commercial purpose on a ship, you need to fulfill certain type approvals. And DNV is one for offshore usage. If you want to use batteries on a commercial basis offshore, you need to have DNV type approval. And it's quite tough to go through that process, but the Nomada battery has the DNV type approval.
Okay. Do most batteries have that?
No. No. There are only very few batteries that have the DNV type approval. And it's like, for example, batteries imported from China almost never have DNV type approval because they cannot meet those tough criteria. So you do not need it, but at least you it's a safe battery because DNV says also it's a good battery to use.
DNV stands for Det Norske Veritas, a standards organization started way back in the mid-1800s that has now created a standard specifically for marine lithium batteries.
But it's recognized all over the world. The design was, if you put them like so, you use a bus bar, you put them now in parallel, and if you put this the other way around, then you have them in series. If you have a luxury yacht and you're in the middle of the ocean, you want to be able to trust on your batteries, right?
I think you're if any kind of yacht and you're in the middle of the ocean.
Yeah, especially for propulsion. I wanted to show you here you see also the BMS, and here you see the what are they? I never know which one it is.
It's some beautiful engineering.
The balancing resistors. So what happens is, let's say here you have in total 8 cells in the battery, right? If 7 of the 8 cells have reached 3.55 volts, it says, okay, I am full. That one cell that still needs the current is, for example, at 3.45. What happens is these balance resistors will convert the current flowing into the BMS. It converts the current into heat, and that only that one cell that's not reached 3.55 volts yet, it will still receive the current. That's how basically the balancing works. And then the BMS communicates with the charger via the CAN network. Until all the batteries are full, it will command the charge, okay, you can now stop charging. And that's why the communicating with the charger is important, because it will also say to the charger, when the battery is at 50%, it will ask the full charge current. When the battery is already almost full, it will say to the charger, I now want to get only like 2 amps. And the charger then needs to provide. It needs to know. That's why you want to have proper communication.
These Nomada batteries by SuperB are designed for large systems, and they can be configured to scale up to our planned energy capacity of 30 kilowatt hours. Each battery has a capacity of 1.34 kilowatt hours at 12 volts. Since we need a 48 volt system, we will make up each bank from 4 batteries in series for a total of 5.3 kilowatt hours. Then when we add 5 more banks in parallel, we stay at 48 volts, but add energy to get a total of 32 kilowatt hours. The final factor for us will be finding space for the batteries, ideally keeping the weight load down.
As always, thanks for watching and for your comments. We read every one, and it's great to have you along on the adventure. And if you want to be even more involved, consider joining our Patreon group, where we have regular get-togethers, Q&As, tutorials, real-time updates, and more. It's a really nice community, and membership helps support the production of Distant Shores videos. We invite you to check it out, and look forward to welcoming you.